Hey guys, today I'm going to teach you two commands, /data modify and /execute store. These are fairly advanced commands, so I'd recommend you have a good amount of knowledge on command blocks, NBT tags, stuff like that. So to teach you these two concepts, I built a tutorial lab in the middle of nowhere. Let's go inside. Okay, as you can see, we have 4 different colored rooms. These are each for different examples that we're going to use and solve on our own. So what we have here is, of course, here's a situation that we have to solve each of them for these signs, and then we have a command block we can use to solve that problem. So first thing we're going to learn is data modify. So what does data modify do? Data modify, if we're going to use these two examples, is going to take NBT from something, and it's going to put that NBT into something else. So let's learn by using a chest. So first of all, what does this mean? How are we going to use data modify? So I've made a template. I'm going to pull it up on screen right now. Now, the template says data modify paste set from copy. So basically what I put here on the signs is the copy and paste. So right here is, I'm going to put this as the copy, and here, this is the paste. Just for easier reference. So basically we're going to plug these things into the command itself. So what I want to do for the first example is, let's say I want my inventory to go into this chest, but I don't want to put it in manually. So let's just take a bunch of random stuff from this menu. Let's randomize it up a bit. That looks fine to me. Okay, so we have a bunch of sand, spruce planks, warp planks, all that kind of stuff. So now we have to get it into this chest. So how are we going to do that? We're going to look at the template that we used from earlier and put it into this command block. So what we're going to do is data modify. It's going to ask for a block, entity, or storage. And here on the template it says paste. So let's read the paste. So on paste it says the chest's item. So what we're trying to do is paste the value into this chest. So looking at the command once more, is the chest a block, entity, or storage? It's a block. Okay. Now it's going to ask for the coordinates of the block. So let's just rip the coordinates right now. Yeah, if you just tab, you can get the coordinates for whatever block you're looking at. Okay, so we know which block to target, and then it's going to ask for a target path. So the target path is just whatever NBT path you're going to take. So let's, for the sake of it, let's put one warp plank in here and then /data get block, and then I'm going to look at this block. So as you can see right here, there is an NBT for items, and this is where all the stored items are in the chest. And that's how this chest stores stuff. So what we're going to look for is the chest's items. And then you're going to get append, insert, merge, prepend, or set. So for the sake of this tutorial, I'm going to teach you what each one does. So if you know how to use arrays, so let's go back here. So if we have this item, so this is in square brackets, which means this is an array. So it can have multiple NBT areas right here. So it doesn't have to have just the warp planks. It can also have other stuff. So pretend that there are multiple items in there. So let's go back to the command block. Append will put whatever you give the value at the beginning. All right, it'll put it at the end, actually. Append will put it at the end. Prepend will put it at the beginning. Insert will put it wherever you want. You could put it as the third value, or the second value, or the fifth value, whatever you want. Merge will just completely wipe the value, whatever is there. And then set will just completely set the value to whatever you put it as. So basically merge is just using data merge, so I wouldn't recommend using merge at all unless you are just like a command enthusiast. So for this sake, we're going to use data modify block and then set. And then we have from and value. So what value does is if you just have to manually input a value, so you can put whatever you want. But when we're making this dynamic, so So I can't just manually input every single block from here and then put it into the chest. I have to make it so that it automatically sets the value for me. So we're going to do set from. And then we have set from copy. So let's read the copy now. So we have the player's inventory. So if we do data get entity on me, I'm going to search for inventory. As you can see, I have the same array. It's kind of just like the chest. But except this one is going to be inventory instead of items. So since we're looking for the player, is the player a block, entity, or storage? Of course, it's an entity. And I am the entity that it's pulling from. And then we're going to look for the NBT. Actually, we're going to look for the NBT path of inventory. And now this is going to be always active. So once we finish this, let's go look at the chest. And as you can see, everything from the hotbar is transferred right into the top row of the chest. And just to test this, let's put one of them away. And just like that, the chest has also put it away. So yeah, this will, just for the chest, it'll only work for everything below, for items 27 below, so anything past the 28th slot won't work. But that's just like one of the limitations you might have to work with. So maybe if you had like a bigger chest, you could work out something with that, but yeah, those are just the limitations. So let's get rid of all of these. Okay, so now that we know how data modify works, let's do a new situation, and let's see if you guys can try to figure this out on your own. Okay, so I have two wolves. One of them I've already tamed right here, and this one's gonna be mine. And this one I have not tamed. It's a regular wolf. So I want to tame this wolf, but I don't have any bones on me. So I want to tame it using commands. Except I don't want to actually tame the wolf by touching it. So what are we going to do? Let's look at the wolf that I've already tamed. So /data get entity. And you're going to see this long line. I think you've already seen it before. But what this line means, so basically if you're looking at any entity, then this is going to be the selector for that entity. So I'm just going to select that. Now, this is going to be all of the wolf's NBT. Let's look at it and see if we can find anything that's related to who owns it. So, we got the owner NBT. It's a long set of numbers. So let's pull that up on the path. Wolf has the following entity data, long set of numbers. So what this is actually, it's a UUID. It's basically a unique tag for each entity so that the game is able to identify it. So this is for the owner. The wolf has its own UUID, which is like somewhere right here. This is actually my UUID. So what the game is doing is this owner ID, whatever the value is, that's the owner of that wolf. And I can prove that by going into I can go into my own entity and then search up UUID. And as you can see, these strings actually match perfectly. So what we're going to do is plug my UUID into this wolf's owner NBT path. So right here, we have the player's UUID and the wolf's owner path. So let's do this with data modify. Data modify. Once again, look at paste. Is the wolf an entity, block, or storage? It's an entity. And then we have to select the wolf using a selector. So I'm just gonna use this long string to specify this specific wolf. All right, now we're gonna look for a target path. And as we showed before, it's gonna be owner. And we don't want to add anything to the UUID. We just want to replace it entirely. And then we want to set it from someone else. So set it from, yeah, I just spoiled that. So we're going to look at copy, the player's UUID. The player is an entity. It's going to be me. And they're going to look for my UUID. So now once I finish this command, that wolf is going to have the owner NBT change to mine. So now the wolf is mine. I set it to no AI, so I can't crouch down. But yeah, that's basically how it works. So it's basically just taking this pet's owner ID and it's setting it to mine so that the wolf automatically belongs to me. And that is all that I have for data modify. So let's move on to execute store. So while data modify is useful for changing stuff like, long strings like of text instead of just like numeric values, but execute store is stuff that we can use to convert. We can convert score, data, all that stuff. And it's actually more useful than you think it is. And not that I mean by, of course, there's too many possibilities that's hard to count. I think execute store is, once you get it, like once it snaps for you, you just immediately understand, and there's just like a world of possibilities for you to learn. So let's look at the first example. So everyone knows about the daylight sensor, hopefully. So if we pull up the daylight sensor, basically what the daylight sensor does is it emits a redstone output if there's sunlight coming in, and if not, it doesn't, and then nighttime is pretty obvious. So the thing with commands is that we can't actually like directly detect what the time is in game. So like we can't go execute if the game time equals 13,000 or something like that. That'd be really cool, but we can't. We can, however, use execute store to replicate that, and it works just as well. So it's the kind of the same template actually. So let me pull this up too. We're going to use execute store result paste run copy. So here's what the objective is. And also what I'm trying to do with this is take the time, whatever time it is right now, and then put it into a score. So if you see on the right, there's actually a sidebar with all this with this info. I already have one, but ignore that. We're trying to convert the global time into a score. So how are we going to do that? Well, let's look at the paste first. So displayed score. Execute store. We have result or success. I'll explain what that is once I'm done with the command. So we're just going to default to result. And then block, boss bar, entity, score, or storage. There's a lot more than before. So here we're going to look at displayed score. And we know that displayed score is obviously a score. And then we're going to choose a player, which is going to be our time, and then an objective, which is info. So the player time will show up here, and then display the time. Okay, so now that we have that down, we're done. There's no more arguments to be made for execute store. So what are we going to do now? Well, now what we need to do is run a command. So we're going to run copy. So what do we have on copy? The global time. But wait, didn't I just say before that we can't execute if game time or something like that? We can't just directly find out if a game time is equal to something else. Actually, we can, but it's a bit more complicated. So let's see first where we can pull up this. So as you know, we can change the time with /time. So let's go there. /time. We have add, query, and set. I think you guys know what add and set do. So set just sets the time, and time add just adds more time. What does query do? That's a weird word. And then we have day, daytime, and game time. Let's do daytime. The game is telling us that the time is 6,480, which is going to be daytime, as you can see. That's weird. Okay, so what if we check day? Time is 1. And for game time, that's going to be a huge number because this world has existed for a long time. So where am I getting at with this? Well, let's see. Let's plug in time query daytime. Because it is, in fact, telling us the global time. Time query daytime. And then done. Interesting. So as you can see here on the right, I have a scoreboard objective, info, and then I have the player time. And the score is going up. And this is actually telling us what the time is right now. So let's go back. So basically what's happening is this command is being run, and then the time is telling however many ticks there are. And however many ticks there are, it's being stored into this score. So, can't select it. So, the command is being run. It's being stored in the time. And I told you I would go back to result. So, result is just, it stores whatever number it gets from here in the command. If we set it to success, it's going to detect if the command is successfully run or not. If it doesn't successfully run, it's going to input a 0, or else it inputs a 1. So this is very useful for numeric values. So let's just test if this scoreboard works by setting the time to 0. Time set 0. And as you can see, the time is reset to 0. Let's try time set 1300. Sure enough, the time is set to 1300 and it's now nighttime. So using that, I created 2 command blocks to tell me if it's daytime or nighttime. So if I step on it's nighttime, it'll obviously work. But if I step on daytime, it's not going to work. And then vice versa. If I set it to day, of course it's daytime, but it's not nighttime. So once again, that's one example of execute store. There's plenty of other stuff that you can do with it. And I'm about to show in the next example, which is actually pretty complicated. So yeah, just a reminder, time query is one of those commands that give you a value and then you can input it into a score. And there's also stuff like scoreboard players get. If you use scoreboard players get, if you get something, so it's going to say I have 1 info, then you can store that into a score. So if you're ever needing to use execute store, you can always use, if you see get in a command, that's basically what execute store is for. There's other stuff you can do with that, such as like attribute, but we're not going into that now. You can figure it out on your own. So here we're going to move into the last example. This is going to be kind of an oddball since like the other ones had clear objectives. This one probably will not. So as you can see, we have a line of Steves. I like calling them Stevies. And as you can see, there are 6 of them. And then we have a little diamond helmet right here. And as you can see, it has a little bit of damage. Ugh, can't drop it. I am doing this all wrong. Let me get this. Okay. I am just gonna, I'm just gonna give the diamond helmet its own home. Yeah. Yeah, stay in there. Okay. So what we want to do is calculate the number of Stevies that are existing, and then however much there are, we're gonna apply damage to the diamond helmet. So as you can see, this is 357 out of 363. That's 6 damage. So that's basically what we want to do, but for any amount of Stevies. Alright, let's put that back in there. So we have a strange pairing. So for this, we have a copy of the amount of Stevies, and then the amount of damage done to the diamond helmet. So let's plug that in. Alright, so we're going to do data modify. No, we're not going to do data modify. We're going to execute store. Execute store result, because we want a variable number that isn't just a 1 or 0. Then we have block boss bar entity score storage. Damage to the diamond helmet. The diamond helmet is an entity right now. So if we do / data get entity, and then we're going to specify this diamond helmet, which is the only item in the game right now. Diamond helmet has the following entity data. We have all this stuff right here, but what we're looking for is damage. So if we go to item, tag, damage. So let's write that down as a path. Item.tag.damage. So when you're working with NBT paths, you can just put a dot instead of putting the brackets itself, which is really useful. So that is the path we're looking for. So let's copy this. So entity, the entity itself, and then the NBT path. And then we have byte, double, float, int, long, and short. Okay, this is kind of weird because we haven't gotten into these kinds of things before. So yeah, once again, let me clear the chat, and then once again pull this up. This. Okay. So do you see these red letters right here? So we have D, S, F, SD, yeah, all that stuff. These things are actually formatted numbers, or I guess number types. So we have byte, double float, int, long, short. And if you take the first letter of each one of them, we have B, D, F, I, L, S. We have F, S, B, D. So basically just take the first letter of byte, double float, int, long, short, and then apply it to whatever number you have. So for motion, you have X, Y, and Z. And each one ends with a D, so that means these are double numbers. For pickup delay, it's 0S, which means it's 0 short numbers. So in terms of what they do in contrast to others, these things really don't matter. Just usually stick to int. So when you're choosing these, you want to make it relative to what MBT you're selecting. So if I wanted to change the pickup delay, then I would set it to short. But here we're selecting damage, and damage doesn't have anything next to it. If a number doesn't have anything next to it, that means it's an integer. So yeah, these things don't really have any difference except for double and float support decimals. That's the biggest difference. Other than that, they're basically all just functioning the same way. But I'd recommend you stick to whichever type of number you're working with. So we're going to do int. And then it's going to ask for a scale. So right here we have a scale. We're just going to set it to 1. So strange thing with data. So if you have a scale and you set it to 2, basically it takes whatever command you run and that whatever number it gives out, it multiplies that number by the scale, and then it inputs the number into data. So here, just leave it as 1. Most of the time, you will just leave it as 1. Don't ever change it unless you know what you're doing. And then we move on. And then we have run copy. The amount of Steves. Okay, so what command are we going to use to find out how many Steves there are? Stevies, actually. So usually we can do we can execute if entity. So let's do that. Execute if entity type equals armor stand. I mean, of course the test passed, but let's look on the right. It says count 6. So normally when we're doing testing or stuff like that, it's kind of useful to see the count right here. It doesn't really do anything. But when we're doing execute store, it actually uses that. So now we can, if we use execute if entity, it will come out with a value of 6, and then it can store that into this diamond helmet. So now this this thing needs no more arguments, even though we just ran execute if entity and then we didn't add anything else. But yeah, that's basically how it works. And you might think that run execute is completely arbitrary, but in this case we're using execute store, so it's completely necessary to use run in this one. Okay, so what are we going to do next? Well, let's just test if this works. So we have 6 DVs, and the diamond helmet was already 357. So what if we drop this away and then remove one of the Stevies? Okay, well now it's 358 out of 363. So if we do the math, that's 5 damage, because there are 5 Stevies. Let's throw it away one more. Then we have 359. So what if we keep doing that? Oops, I accidentally destroyed the testing lab. Okay, so now we got 362 out of 363, that's 1. And if we destroy the last TV, and then, repick it back up, then it's fully repaired. And of course, if we add more armor stands, then we can damage it even more. And this one's going to be 355 out of 363, so that would be 8. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, that is basically how execute, store, and data modify work. And as you can see, we have 4 examples that we went over. Yeah, gotta put that away. So yeah, even with these examples, you can use these specific ones for any situation that you might have. And just remember that for data modify, you are mostly using that for stuff like text or arrays or numbers or groups of stuff like that. And then for execute store, you're converting numbers into other types of code like data, score, or storages. And if you don't know, storages are basically like places that you can put NBT data into. Those are also useful, so I'd recommend looking at those. But other than that, I hope you guys learned something today, and I'll see you another time. Bye.